Hello, this is Dr. Joe Trout from the physics program at Stockton University. This video discusses spreadsheets, and we continue our discussion on formulas and functions and introduce how to plot data in a chart. Don't forget, as soon as you open up your spreadsheet, go to cell A1 and type your name, so in case you send me the spreadsheet, I can go ahead and know who it's from right away. Now we want to know how to insert charts into our spreadsheet, so we need some data. Normally the horizontal axis is called the independent axis, and I've just typed in some numbers for x, so the numbers 1 through 8. And we're going to have some data that depends on x, so y is the dependent axis, and I'm going to type in an equation here to make up some data. So I'm going to say it's equal to 4 times x, and I'm going to click on the cell A6 because that's my x value, plus 10. So that's 4 times 1 plus 10 should be 14. And it is. Now I need 7 more data points, so I can go ahead and type in the equation again. Don't forget, equations have to start with an equal sign. And 4 times, this time it'll be A7, so 4 times x plus 10, and type it in. And we get 18 this time. Now I could probably quickly type in another 6 equations and it won't take too much time, but if there was 100 numbers or 100 x values, this would become quickly monotonous. So let me go ahead and get rid of this. Excel is smart enough to do the work for you, or the programmers which wrote Excel are smart enough that Excel can do the work for you. And I want this same equation in all these boxes, but I want the x values to increment as they go up. So there's something called a fill down, and there's a little fill down or fill box on the right. If you notice right now, my cursor is fat plus sign. If I move it over to the little green box in the corner here and lay it over top, it becomes the thin plus sign. Once it's a thin plus sign, if I click the mouse button and hold it down and then drag the mouse down to fill up the boxes, what happens is your spreadsheet has put in the equation in every one of these boxes. Now I want to go ahead and see what this data looks like. So charts are a good way to quickly look at data and see if there's any kind of pattern. So how to do this is we're going to go ahead and insert an XY scatter plot. An XY scatter plot is probably the most popular chart or plot in science and engineering. We can do that by inserting this chart Make sure that you're using the XY scatter plot when you want to, when you're doing some of these assignments. There's something similar up here that's called a line chart, and that's used more in business and industry. So let's go ahead and insert the chart. The easiest way to do this, and once again, as I said before, there's a couple of billion ways to do every action in Excel, so I'm going to show you my favorite way. What we can do is highlight the data, and how you do that is you click on the first data cell, and you can include these data labels here. So click on the X, and then holding the mouse button down, we'll go ahead and highlight all the data. Now we'll go up to Insert and a Scatter Plot. Some of you may already know what this chart is going to look like, what this data will look like once it's in the chart. Do you think you know what it will look like? Well, let's see if you're correct. Now that the data is highlighted, all I have to do is click on the XY scatter plot or scatter chart. Normally, you have raw data points like we have here. You put them as points. You can also connect lines between the points, and if you notice, the chart is updating as I do this, or just lines. Right? Lines with straight lines between the markers. This was curved lines between the markers, but in this case it's a straight line. But once again, if you have raw data points, you usually just put them in as points. If you thought the data would look like it lie along a straight line, you're correct. And here's our straight line. The reason it rides on a straight line is because this equation has the form of y equals mx plus b. So our equation was y equals 4 times x plus 10. If you've never seen this equation before, or if what I'm saying is Greek to you, go ahead and watch the video on linear equations, or the equation of a line. The m here is called the slope, and that's how much y changes as x increases. So every time I increase x1 space, y is incremented by 4. So note, as I go from, my first value is x equals 1, y equals 14. If I increase x by 1, the next value is 14 plus 4 is 18. If I increase it 1 again, it's 18 plus 4 is 22. So this is known as the slope of this line. You may have heard it called change in y over change in x, or rise over run, but it's the slope. Do you know what the b stands for? If you said it stands for the y-intercept, or where the line crosses the y-axis, you're correct. So if I follow this line straight back until it crossed the y-axis, it would cross the y-axis at a value of 10. So m is what we call our slope, and b is our y-intercept, sometimes just called the intercept. Don't forget, if your entries are larger than the cell, you can move your mouse button up to the space between A and B. Your cursor will change. If you double click, it'll change the cell sizes for that column to fit your data or your entries. Let's pretend that we put this data in and we didn't know what the slope and the y-intercept was. Well, Excel has a function that will help you find that. If you don't remember what the function name, just start typing out what you believe the word might be, like slope, and Excel will give you a list of possible functions. Here we see slope returns the slope of a linear regression line through the given data points. If we double click on it, it'll print it in the box for us, and it'll tell us what to do. So what it says is to put the known y values in, comma, the known x values in. Now you don't have to type in the known y values. All you have to do is highlight them. Once again, how to highlight is go to the center of the box, click with the left mouse button, hold that mouse button down, and select the data you want. So there's our y values, and then comma our x values. Click on the center of the box, hold the mouse button down, and select the points you want. This time, do not include the name of the data points or you'll get an error. Then go ahead and close the parentheses, and Excel found our slope for us. It's 4. If I want to find the intercept of the line, once again, I can start typing in the word. The spreadsheet found it for us. It's intercept. And this calculates the point at which the line will intersect the y-axis using a best fit regression plotted through the known x and y values. So that sounds like the right one. If we double click, it says put in the known y values. Comma, put in the known x values. And what should the value be? If you said 10, you're correct. Scientists and engineers love to find data that lies in a straight line like this, because then we know what the value is of the equation, or what the equation looks like, very quickly. Spreadsheets have a function called trendline, which will go ahead and try to figure out the equation for us. To find the trend line, what you do is click on the chart, click on one of the data points. Now notice it highlighted a bunch of the data points for you. In this case, it highlighted all of them. If you click with the right hand mouse button, so the opposite mouse button that you usually use, a menu will come up and you can add a trend line. another menu box will come up, and there's a bunch of trend lines that you can choose from. For now, just keep the linear trend line, and if you go to the bottom of this list, you can display the equation on the chart and display the r squared value. The spreadsheet found the right equation. It's 4 times x plus 10, and r squared is equal to 1. Do you know what this r squared value is? What it signifies? Well, the r squared value will tell you how well this equation fits the data. And r squared equals 1 means that all of the points lie on the trend line you set up. And don't forget, this is the equation of the trend line. So r squared is a value between 0 and 1. And 1 means that all the data points lie on the trend line. By the way, this is a rather large menu box. If you want to get it out of the way, you can just click the X here and it will close it for you. Let's try another example. Here I have some data which I made up ahead of time. And a lot of times, the data approximates a straight line. But for instance, maybe this was data that was gotten during an experiment. And nobody's perfect. So every time we make a measurement, we could make a little mistake. So even data points that lie on a straight line, if we make the measurements, they may be a little bit off of that line. In this case, what this was the position of some object, x, versus the time. So at time 0, its position was negative 4.3. A tenth of a second later, it was at 4.25. A tenth of a second later, it's at 3.31. So let's go ahead and place this data in a scatter plot. Once again, go to the center of the cell of the first cell you're interested in. In this case, it's the label for the x-axis or the independent axis. But before I forget, if you notice, there's a parentheses with an S in it for the time, and a parentheses with an M in it for the meters. These are the units, and whenever you have data, you should have units associated with it. So the position is in meters, and the time is in seconds. Now let's go ahead and insert a scatter plot. Go to the first cell of interest, click in the center of the cell, hold the mouse button down, drag it until you select all the cells that you want. We'll go ahead and insert a scatter plot. We want just points. And here's my data. Now this clearly isn't a straight line, but it can be approximated by a straight line. So for instance, you can imagine taking a ruler and dragging it down and coming up with a straight line that's pretty close to all the points. Don't forget this chart is not complete. It needs a horizontal axis title and a vertical axis title. Sorry about that. Our x-axis, or our horizontal axis, is actually time from our data point. And our vertical axis is x. And once again, if you can, you want to go ahead and put the units in for this. Our title also isn't very good. Just says x is meters. What we should say is that this is x versus time, or if you'd like, position versus time. Once again, we can approximate this by a straight line. And if we click on one of the data points and highlight all the data points, then click with the right hand mouse button and add a trend line, we can try these other trend lines. What you just saw is that when you try some of them, the first one we tried was a logarithm, and if you click on logarithm by accident, it will give you an error because some of the values are negative, and if you know anything about logarithms, they can't be negative. Once again, we want to draw in our best straight line, so we'll use the linear trend line. And once again, we'll click on display equation on chart and the r squared value. And I'm going to go ahead and close this dialog or menu box. And I'm going to drag the trend line up so we can see it. Here the slope is 3.8, so every time x increases by 1 for the trend line, y increases 3.8. And our y-intercept is negative 4.4. Notice our r squared value isn't 1 this time. It's 0.97, which is pretty close to 1. So this did a pretty good job at coming up with an equation to explain the data. And all the lines are pretty close to that straight line. One strange thing to notice is that although some of these points come awful close, none of these points actually lie on the trend line. So once again, maybe the experiment I did, the relationship actually was linear, but I was a little sloppy in my measurements, and this is what happens. Or another way to look at this is that this is what happens in nature. We have a bunch of data points, and we try to approximate the data points with an equation that will explain the trend of these data points. That being said, we don't always use, I told you that most of the time we use XY scatter plots. But if we have something like rainfall, a lot of times that's shown as a bar chart. This is why. It's really hard to predict rainfall. Because, for instance, sometimes it's raining in Galloway and not in Atlantic City. Right? Two places that are very close together, and one gets rain and the other one doesn't. So what we'll find is that rainfall is much more variable, right? We can pretty much predict what's going to happen to the temperature around Galloway. In the winter it's going to get cold, in the summer it's going to get hot. In the winter it's going to get cold, in the summer it's going to get hot. And we can predict pretty easily roughly what the temperature will be on any given day. We can't pinpoint it, but just by looking at averages, we know that January 20th of one year is similar to January 20th of another year. But rain is much more variable. And sometimes we have droughts that last for years, or all of a sudden we get horrible, horrible rainfall and we have flooding everywhere. So it's a lot more variable. So traditionally, things like rainfall, and this is the rainfall in Galloway that happened this year or happened last year. And we can go ahead and highlight this data, and instead of using an XY scatter plot, we'll use a column chart. Also, when we want to go ahead and plot this using the column chart, assuming that the x-axis is uniform like this, it goes from 1 to 12, you can just highlight the y-axis and insert our column chart, and what we get is a column that looks like this. Don't forget, we always want to have our axis titles in there. This time our axis title, our x-axis or our horizontal axis, is time, and the units are months. And our vertical axis is rainfall, and the units are centimeters. We also might want to give it a better name. Sorry, I just got rid of that huge menu window so you could see a little bit better. Okay, and what we said was that this was the rainfall in Galloway, New Jersey. So let's try another chart. Here I have some data I made up, and it's x versus y. By the way, notice that the default is that text is left justified and numbers are right justified. If you'd like, you can change that. We can go ahead and highlight the data and make it center justified. Maybe you like that better. We can go ahead and change the format of our data labels. We can go ahead and put it in boxes or put borders around it. Okay, so we can, if we call this a table, we can format the table any way we want. Now let's go ahead and see what this data looks like. So right now they're just a bunch of numbers. You don't probably realize any pattern. But as soon as I put it into a chart form, you can see there is a pattern there. So some of you might know what equation I use to get this. But let's see if Excel can figure it out for us, or your spreadsheet can figure it out for us. We'll plot on the line. We'll click with the right-hand mouse button, add a trend line. Well, clearly, a linear line, a straight line, would not represent this data very well. So let's try something else. We could try an exponential. It doesn't do bad, but it's still not great. By the way, let's go ahead and click on our display equations and our r-squared value. You can see our r-squared value hasn't done really well. Okay, and we can go ahead and format this. Let's go back to our trend line. An exponential doesn't seem to have done so well. We're not going to use a logarithmic because there's some negative values there. Let's try a power fit. This says that it can't be used either because there's negative or zero values. Oops. Sorry, I clicked on the wrong thing. Once again, we'll display the equation on the chart. So the only one we haven't tried yet is the polynomial. The moving average you hardly ever use, so I won't talk about that right now. Try the polynomial, and that fit the equation perfectly, right? The r-squared value tells us that all the points lie on that trend line. And this is a polynomial, so to get each one of these data points, it's 2x squared. Let me make it a little larger so you can see it. It's 2x squared plus 3x plus 5. So for instance, let's check out the number 1. So that's 2 times 1 squared, and 1 squared is 1. So that's 2. Plus 3 times 1 is 5. Plus 5 is 10. Let's go ahead and try 2. 2 times 2 squared. 2 squared is 4. So squared means take the number times itself. So that's 2 times 2 is 4. Times 2 is 8. Plus 3 times 2 is 6. So that's 14. Plus 5, we get 19. So now we know the equation which represents this data. I'm going to move the trend line out of the way. Don't forget, we need to go ahead and put in sorry, I don't have the chart highlighted. We need to go ahead and put in our chart titles, our axis titles, so the primary horizontal, and the primary vertical. Once again, this is just a plot of y versus x. And we should change the title to a little bit better than just y. We'll say y versus x. Let's do one more example. Here I have a bunch of temperature data for the years 1873 to 1893, and they're the averages for each month. In China, at the longitude of 121.47 degrees and the latitude of 31.4 degrees. For your final project, what you're going to do is talk about the climate of some area that I assign to you, and you'll be given data like this. When we talk about the climate, we usually talk about averages and maximum and minimums. So what we want to know is what the average temperature is, and the max temperature. Don't forget, this is the maximum average of the year, and the minimum temperature. If we look across this line, we can figure out what the maximum temperature is. It's 30. And if you want to find the minimum temperature, we'll look around. Looks like it's 4.7. Now here is approximately, this is 1873 to 1893, about 20 years. So I suppose you could go ahead and search each one of these and find out what the max and min is each year. But you're going to be given approximately 100 years of data. So let's let the spreadsheet do the work for us. There's a function max, and if I highlight the data, it'll figure out what the maximum value is for those 12 months in 1873. There's also a function called min, and that'll find the minimum values. And of course, there's a function that finds the average, and it's the word average. And we can find the average value. Now, instead of typing these all in, these functions in over and over and over again, we can use the fill down box. And one good thing is that you could do multiple columns or multiple rows. In this case, we want to fill down all three of these functions. We go to the little green fill down box. Our cursor changes. We click with the left hand mouse button and hold the mouse button down and fill down, and it finds all the values for us. So let's go ahead and plot the average, the maximum, and the minimum all on one chart, and we want it as a function of a year. The year is way over here, so we can't do this. That won't work. We can't highlight all of these. The idea is that you could click on the year and hold your mouse button down till you get to the end of the data, and then hit the control key if you're using a PC, and move over and click on these values that you want to plot and highlight them. So once again, click on the center of the first box, or cell, excuse me. Hold the mouse button down. When you get to the bottom of the column, hit the control key, release the mouse button, move over to the other data, click on the mouse button and hold it down and highlight. One more time. Click on the first value, hold the mouse button down, highlight these, hit the control button, keep holding the control button, release the mouse button, move over to your data, click in the center, and highlight. We'll go ahead and insert an XY scatter plot. And not surprisingly, the average temperature through the year doesn't change a whole lot. There's variation, but the average is somewhere around 18, right? Or about 17.5. The maximum temperature doesn't change very much. It's usually around 30 degrees C. And our minimum is somewhere around 5 degrees C. It'd be interesting to look and see if the country's getting warmer or colder, or that location's getting warmer or colder as the years go on. So is there any global warming or cooling going on? To do this, we'll use a trend line. We click on the data points, add a trend line. We'll use linear. We'll set the display the equation, display the r squared value, and close the box. And it looks like our maximum temperature is increasing each year by 0.16 degrees. We can do the same thing for the average, so we can have multiple trend lines explaining multiple data on the same chart. And once again, this slope tells us that the average temperature is increasing about 0.00228 degrees each year. We'll talk more about this when we discuss the project. Right now, we're just trying to learn how to graph or chart and how to put in trend lines. And that's what we did here. Notice that since we have multiple sets of data on here, there's something called a legend. And the legend tells us that the blue is average T, the orange is maximum T, the gray is minimum T, and these dotted lines are the linear fits. Don't forget, we have to add in our chart title. Okay, so call it something appropriate like temperature in China. You should probably also put the latitude and longitude here, but just to save a little time, I'll let you do that. We also need axis titles, primary horizontal and primary vertical. Our x-axis is time and the value is, or the unit is a year, and our y-axis is temperature in degrees Celsius. Don't forget, in some of your exercises, it just tells you to chart the data or plot the data, and you don't have to do the trend line. And in some exercises, you'll have to add the trend line. Okay, so I hope this helps you out. Once again, if you don't know anything about linear equations or the equation of a line, there'll be a video for you to watch. Okay, thank you.